Hi, my name is Wanda Gass, and I am an employee of Texas Instruments. I worked there for 31 years before I retired, and now I am doing something that really makes me happy, and that's the topic of today's talk. It's a summer program that we offer to girls where they come for 2 weeks the summer before they take physics to learn in an environment that's supportive and gets them hands-on experience to physics before they have to go into a formal environment and compete with the boys to get their hands on the equipment. So today I'm going to talk about how physics is tough, but girls are actually tougher. So this is presented by a new nonprofit called Design, Connect, Create. So exactly what is the situation? It looks like we've taken a step backwards slightly from 2004 to 2014 in a 10-year period. We went from 20% bachelor's degrees to 19% in terms of representation of women in those fields. On the other hand, it looks like we've made progress on the master's and doctoral side, but something kind of tells me that those numbers in the master's and doctoral program may be because of the influx of international women coming to the United States to get the graduate degrees. So maybe you're asking yourself, well, if women are interested, they're going to do it. If they're not, why should we change their mind? What does it matter to me if there's not as many women as men in the field? So there's 3 reasons why I think it matters that we have more females in the field of engineering. First, there's a demand for more technical workforce in the future. And if we only ask half of our population to be interested in that, then we're probably not going to get to the numbers we need to fill the demand. So we need to include everybody in all parts of the world to help us achieve the technology experience and literacy that we need to actually help us advance in the future. The second reason why I think we need to include more females in engineering is because when you have a mixture of people, a diverse set of people working on a problem, they bring their perspective to solving the problem. You actually get a better solution. You have a wider set of experiences, and therefore you come up with a more innovative solution. This is actually a good reason why corporations should look at increasing their diversity of gender, because they actually have found that women CEOs and companies with women on the boards actually make more money than companies that are all male. So we also would like for women to be involved in high-paying, fast-growing jobs to provide them with economic security. And if that's better represented by both men and women going into this field, to give everyone the economic security that an engineering job would provide. So what is it we're doing in this program? We have a 2-week day camp, so it's not an overnight camp. It's where students come during the summer, and they come the summer before they take physics. We obviously cover physics topics. The first week that we have the camp, they work on electricity as the first units that they do. We start with simple circuits where we turn off and on light bulbs. We hook them up in parallel. We hook them up in series. And eventually we do this with light bulbs so that they can see the effect of what's going on visually. And we also use resistors, and eventually we derive Ohm's law. But we have a circuit design task that each lab group has to do on the last day of that week, where they come up with their own circuit, and then they cover everything up with the light bulbs. so that you can't see how the circuit's hooked up. And each of the other lab groups comes around, and by twisting off the light bulbs and twisting them back on, they try to reverse engineer what the circuit scenario is that's hidden from them. And so each of the lab groups gets to do their own circuit like that. We have collaborative efforts throughout the camp. We change the lab groups up so that people get to meet different lab partners each day. We present information in teacher demonstrations that are relevant to what they're experiencing in life. We do a lot of hands-on experiments where they get to touch and feel and understand the concepts. Because there's no grade in summer camp, we can have a lot of fun, and there's no stress of grades, so it makes it something that the girls have to work for, but they get a lot of enjoyment out of as well. The second week of camp is focusing on motion. We start out the first day with velocity, talk about constant velocity, and then we move into acceleration on the second day and talk about vectors and eventually to trajectories, where the girls get to do things like walk through mazes to figure out what the vectors are. They work with toy cars on the floor to understand velocity and plot those. We work with gravity when we talk about acceleration, and eventually we do a hit the target exercise when we talk about trajectories. It's a lot of fun, and the girls seem to get a lot out of it. We also integrate math as well as physics, so that the math lessons go with the physics that we're studying. We also do a unit on 3D spatialization skulls, so that they can get familiar with that. And we bring in speakers to talk about their careers. In addition to what we teach them, a key component of the camp is how we teach them. So one of the things we promote at the camp is to talk about a concept called growth mindset. Growth mindset is the idea that if you work hard, you can learn more. That intelligence is not a fixed commodity that you're born with, but it's something that grows over time, and the more effort you put into it, the smarter you can get. So we show them that in the brain, or actually in other, that there's electric pathways that are created and grown where axon tips connect to dendrites, through dendrites to synapses, that actually creates the pathway that allows you to learn. And the more you learn, the more dendrites you grow, and the more axons and synapses are created. So if the reason we teach this is if they run into something that's difficult and is challenging them, that if they persist in struggling with the concept until they understand it, that they've actually increased their intelligence, and that they should look at challenges as opportunities to learn, as opposed to barriers that should prevent them, should cause them to give up and turn away. So we know that math and physics can be challenging, but persistence and continuing to strive to learn is really the key behind what we're teaching at camp. Another how we teach is we talk to them about a theory called Stereotype Threat. And this is actually documented in a book called Whistling Vivaldi. It's by Claude Steele. And so there's several things that we do throughout the camp that helps them understand that there is a stereotype threat, and what they can do to maybe overcome some of this, and what we can do as instructors in the camp to help keep stereotype threat from happening to the girls. This is a concept. The definition of stereotype threat is when somebody who's been socialized as being less capable because of a gender, a race, a certain economic background, that they are either less athletically capable, intellectually capable, or whatever the scenario may be. Stereotype threat is when they are afraid they're going to confirm the stereotype, and therefore that anxiousness causes them to underperform. So some of the things we can do to eliminate stereotype threat that we do in the camp is we talk about self-affirmation. Self-affirmation is what are the goals that you're setting for yourself, and why are you here, and what is it that you hope to gain out of this situation? Because if you set those goals up early in the camp, then they will carry you through and help you maybe get through those challenges a little bit easier and better because you have some goals in mind for why you're there. Another way that we combat stereotype threat is we set high standards and expectations during the camp, but we also support them with assurances that we know that if they work hard, they're capable of getting to that aha moment. So we really support them and assure them that they're really capable, and this alleviates some of that stereotype threat. The third thing we can do is talk about the previous slide, which is an incremental view of ability. In other words, your intelligence is not fixed, but as the harder you work at it, the more you grow and the better you can get at something. So being able to understand that hard work leads to learning. And the last thing we do to remove the stereotype threat is to bring in people that look like them to talk about their careers. And so we invite women who are in the STEM fields, science, technology, engineering, or math, to come and talk to them about their educational background and what they did in college and what they did when they started their career and what their career looks like, and why other women might want to do the same type of career that they have. The reference at the bottom of the screen is a URL where you can go to find out more about reducing stereotype threat. So role models. When you talk about engineers, or maybe in this case physicists, there's probably some images that come to mind, and a lot of people will think of Albert Einstein, who obviously developed the theory of relativity. Well, we do cover the theory of relativity in the camp, but we don't just present Albert Einstein as the only physicist or scientist or engineer that they see. Another person that might have popped into your mind when you heard the word physicist might have been Sheldon Cooper from The Big Bang Theory. Again, it's quite popular by media to think of these types of people when you think of scientists or engineers. And actually, if that's the only perception that girls have of physicists and engineers, they're probably not going to want to be one. So what we do is we talk to them about other people, such as Ellen Ochoa, who was a Hispanic astronaut. She was the first female Hispanic astronaut to go into outer space, or Mae Jemison, who was the first African American to go into outer space. So we needed to talk to them about other role models that they can think of that might look like them or have come from their background. And this is Valerie Thomas, who was also at NASA, but she was an assistant director of the Data and Operations Unit, but she also invented a 3D display. These are the type of role models that we want to talk to them about while they're at camp. We also, in addition to bringing in AP Physics teachers from high school to teach the camp, we also hire teaching assistants of girls that are in college who are studying engineering or science to be a helper in the camp, but they also help them with their assignments. They help them with the labs. They talk to them about what it's like to be at college. They talk to them about the college admission process. We even bring on admissions officers from some colleges to talk to them about when to apply, how to get scholarships, so they get a better insight into what the college experience is all about. In one case, we have the camps on a college campus, so the girls get to come to the college campus during the day, and we take them on a tour of the colleges while they're there. Another thing we do is we bring in speakers from industry to talk about what it's like to be in an engineering field and how engineering is a global demand, and many companies will be international in their scope and how they employ people in the workforce and where their customer base is. So we talk to them about what it's like to be an engineer in a company, and we also take them on a field trip to visit a local company to see what it looks like in the offices and what kind of neat projects they're working on, so that they can get a better understanding of what an engineer does. Another aspect of the camps is the teachers do demonstrations in the morning, and they do those demonstrations to give the students who are maybe a little bit more of a visual learner some ideas, but they also tie it back to everyday examples that are relevant to our lives. For example, one day we bring in some liquid nitrogen, which allows us to talk about what happens from a physical standpoint when things are very, very cold. And so what property do they take on when the temperature is really low, and how that affects the magnetism of the thing, how it affects the volume of something, and what it feels like. And we make sure that there's safety involved, but they learn all the different kinds of things that happen when things are very, very cold. That's a fun thing, because at the end of that demonstration, they get to make ice cream out of liquid nitrogen. So that's something that they get to experience and taste, and they seem to like that activity the most of all the ones we do during the week. Another thing we talk about is air pressure. So we have built a little hovercraft that we can sit on, and the girls get to sit on that when the leaf blower is turned on. They are elevated from the floor, so basically there's no more friction. So when they're pushed down the hallway, they slide without any kind of slowing down of motion, and then they're caught on the other end, and then they get to go back the other way. So it's a really fun activity that they get to experience by riding on the hovercraft. Another example is when we study waves, we use a Chandra plate, and that allows us to show what waves look like in a two-dimensional sense, and it allows them to see, as we turn up the frequency, different patterns are showed on the plate, so that they can actually see the interaction of a 2D wave as opposed to just hear it in an auditory sense. And the fourth thing that this is illustrated on this slide is our discussion of optics, where we have a concave and a convex mirror, and we talk to them about optics and lenses and how light is transmitted through the lenses and what to expect from that opportunity on the camp. Another thing that's a part of the camp that we offer during the summer is the idea that we are trying to promote collaboration rather than competition. And so obviously when they're in groups, we put them in groups of 3 for the lab activities, but the very last day of camp, we have an activity that's called a physics bowl, and it's basically a game, a contest, where we put questions up on the board, and they are broken up into teams of 3. Each team gets to submit an answer. we do put a time limit on each question, and the answers are taken up after the time limit is up, and they're graded to see which team got the most answers correct. But because it's in a group of 3, they can leverage off of each other's knowledge and support each other in a kind of gaming environment. And we believe that teaching collaboration in sciences and engineering is really key, because it's really a collaborative effort to come up with an innovative idea. If you can't leverage what's gone on before you, then you are going to be reinventing the wheel every time. So we believe that the key to a successful career in engineering is to learn that collaboration. Another element of the camp is what girls say when we do the post-camp survey. So they tell us what they liked about the camp, and what, after it's over with, what was the highlight of the camp. We have found that they enjoy the teacher demonstrations that happen in the morning. We actually call them wake-up activities. They like the fact that when they're either doing a lab or a worksheet assignment, that if they have a problem and they raise their hand, that someone is there pretty quickly to help them with the problem. If they explain it, if it was explained one way and they still don't get it, we change the explanation and try it from a different angle, and we reword the problem for them so that they can get to that point where they understand the concept. We don't have any grades during the camp, so instead of emphasizing memorization, we really want them to get the concepts down. And so there's always time for questions if they don't understand, and lots of hands-on experimentation during the camp. They also like the fact that there's other girls in the camp that are not from their school, so they get to meet other kids. And for women, it seems to be really key that we have a lot of social interaction going on, so that they feel comfortable. That's something that seems to draw the girls to the camp, is to have relationships not only with the people in their school, but across the district to other schools. So what has been the results of having this? This camp was actually started 12 years ago, so we have some longitudinal data that we can look back on. Before we started camp, there was a gap between the performance of the girls and the boys. So this line right here is AP test exams that were taken by boys, this blue line at the top. And you can see that boys were passing at about 35% of the tests were passing. For girls, the rate was down at 15%. So there's a pretty big gap there, close to 20% percentage points lower for the women taking AP exams compared to the boys. And this was consistent for 3 or 4 years. Both of them improved over time due to an AP incentive program that was put in place by the district. But when we started the camps, we found out that the girls that had gone to the camp were passing at a much higher rate than the girls that hadn't gone to camp. So the pink line is the overall average of pass rate for the whole district, but the red line is the girls that had attended camp, and the orange line is the girls that had not attended camp. So you can see that the camp created a performance improvement that basically closed the gap between the men and the women in terms of passing AP exams. We were also able to track the graduating class of 2006, and based on math test scores from 8th and 9th grade, we created a control group of high-performing girls in the math area. And we tracked those past graduation, where the intervention group had gone to camp and the non-intervention group was also tracked. and we found out that the girls that graduated with a college degree, that 45% of them that had gone to camp ended up earning a STEM degree, and that only 17% of the girls that had not gone to camp earned a STEM degree. And we found that when we asked the girls before camp if they were interested in a science, engineering, or math degree career that required those subjects, that about half of them weren't interested when they first started camp, but in the post-camp survey, it was over 90% of the girls were definitely interested in a science, engineering, or math type of career. So we know that the camps really improved their interest in these subjects, and it looks like it has paid off into what degree they actually earned when they finished college. So, to summarize what this talk is about, it's about a physics camp for girls. We believe that although physics is tough, that girls are tougher. And if you're interested in having this kind of impact in your local community, we would invite companies that would like to bring the camp to their local schools, to their local school districts, to get in touch with me, and we can offer the camp to your in your local area, either at a high school of your choice, or if there's somebody in a university that needs to implement a summer outreach program on their camp, on their campus, we would be glad to talk to you about how to deliver the physics camp for girls at your campus. And so if you can contact me at gass@designconnectcreate.org, or you can visit the website. You can find out a little bit more about the camp. We'd be glad to talk about bringing it to your university or your community. Thank you.